Okay, so today's video is going to be a little bit different. Someone was curious how I actually put these circuit boards together for the prototypes that I do. So we're going to take a dive into how these little guys are made. So first up right here you see a SMD stencil. So almost all of the components on this board are surface mount, so they don't have through holes. So instead what we use is a solder paste, and it helps the components stay on the board, and it saves a lot of space because of how tiny they are. So what we do is we take this solder paste and we swipe it over top of this stencil, and it forces the paste inside all the little squares and holes. So that way the paste only ends up on the pads and not all over the board, because that would be a big old mess. So usually you're only supposed to swipe this once, but I had to dab it a few times. This was my first SMD assembly, by the way, so yeah, forgive any amateur hour mistakes, but this was just me learning how to put these together just to see if I could do it. But anyway, after you do a wonderful pass, all the pads have paste and they're good to go. So now that the sticky stuff has been applied, we get to do the fun part of populating the board by hand. So we got a bunch of little baggies and a bunch of little chips. Sadly you can't eat these, they're not very tasty. And we pick them up and we put them down over and over and over again. Very carefully too. So yeah, when I first started I was using little needle nose pliers, but now I have some more professional tweezers that really help with the smaller stuff, as you'll see later. If this is small, just wait. So now that I put the main chip on, we're going to start doing some slightly smaller components. I think this is an SOIC style chip. They're kind of small, but not super small. You'll see later. So we just slowly pick our pieces and put them down, making sure the orientation is correct and they're sitting. Give them a little tap just to make sure they're definitely stuck. Now here is flux. This is like a gel type, and what this does, it basically helps to clean the board and help the solder, which is like the melted metal, stick to the pads better. But I'm also using it to just hold the chip in place, because that one has really tiny pads and it's a pain in the butt to make sure it's on there straight. So the flux helps everything, it helps the solder flow better. So now we're going to move down to smaller components. These are 1206 size components. These are some polyfuses, so that way people can't blow things up if they try to run too much power through them. So as you can see there, I got to be real careful not to nudge other components. So I try to do the big ones first and then the smaller ones later. And here is some smaller. So these are 0603. These are as small as I wanted to go on this first test, because I've never done SMD before, so I just wanted to see how I could do it. So I'm actually using a little bit of paste on that small flathead to pick these components up. It's just sticky enough that they get picked up and put back down. So yeah, that is very, very delicate work. Just making sure that they're placed where they need to be. I could have went 0402, but those things are microscopic. So the tweezers that I have now, I might be able to pull it off, but you know, I won't go that route unless I absolutely have to. Or if someone else puts them together. Again, I'm only doing this by hand for prototypes, just because it's faster to get the boards and do them myself than wait 3 weeks for the PCB manufacturer to do them. So anyway, here's a close-up of what I'm actually doing, moving little grains of rice around. So these are capacitors right here. Again, these are all 0603 components. I think that's the size in like millimeters or something. 0.6 by 0.3, maybe? I don't know. But you pick them up and you put them into the little squishy stuff. So that's the nice thing about the paste, is it not only is it the solder, but it also helps the components not move around. So you can actually pick the thing up when you're done and not watch all your things blow away. So I've got other things in here. We've got crystals and buttons and jacks and just about everything you can think of. So the last part right here is the micro USB ports. I'm just going to put them in place and make sure all the little pins in the back line up. I might go with ones that have tabs later, so that way they index to the board properly. You don't have to worry about if they're sitting where they're supposed to or not. You know that if they're in the holes, they're lined up. But, you know, all part of the learning process. See what works and what doesn't. So here we got some little push buttons over here. Make sure they're sitting where they need to. This in particular is for the reset, so it'll turn the bootloader on for the board so we can actually program them later. And not to bore you too much, but I just wanted to show, you know, what an average assembly looks like. Just taking little tiny bits and putting them on there and taking out the next pack and putting some more on. Each one's have different values. I'll usually do them in like small batches. I'll do like anywhere from like 3 to 6 boards at a time. Because it's a lot more efficient than just doing one board completely than doing the next board completely. By doing them like this, you know, you're not opening the bags a billion times. And it's a little easy to remember where the components are. So now when I'm doing rework, I got these little guys. Rhino, Switzerland standard. These are anti-acid, non-magnetic, really pointy, and great for picking up all kinds of little things. Pick it up and put it wherever the heck you need it. Super easily. The nice thing is it actually lets go once you pick it up. Non-magnetic, baby. Good stuff. Okay, so now on to the fun stuff. Here we have ourselves a glorified hairdryer, basically. It's a hot air rework station, and basically all it does is it's a big machine that makes hot air. And the air coming out of that tip is actually hot enough to melt the solder. Pretty cool stuff. So let's get a good close-up into that. You can listen to the sweet sound of Louis Rossman in the background.
We really don't have all day and all night and all afternoon.
It's nice to listen to podcast or music or something like that to make the time go by, so you're not just going crazy messing around with all these boards.
We're going to put that capacitor right where it belongs. Yep. Or not.
But it's really cool to watch the all the solder melt into place and all the components just wick into where they need to be. It's really fun to watch.
The 40-inch Siki.
But you do have to be careful with some components, like especially the capacitors. For some reason, they like to pop up a lot, so I got to use that little flathead to push them down. I'm thinking next batch I'm going to try some kind of reflow oven. I've heard a lot of people have luck with toaster ovens, so I might buy myself a cheap toaster oven and see if I can cook my boards and do the same thing I'm doing here, but properly and faster and hopefully better.
Myself some dental floss.
Here's one that popped up there. I can knock it back down.
Moving to Montana soon.
Voltage regulator chip over there is always a pain, so I always try to poke it and see if it wiggles, make sure it bounces back so I know all the pads are holding it together. And we're good to go. There you go. That's what a finished board looks like when all the pieces are together. Ain't that pretty? So, after we're done playing around with the hot air, I like to check my boards. I have a pinout, so I have ground and 5 volts. And once I find all the components are where they should be, get that nice visual inspection. Don't mind the nerd goggles. We take out our multimeter, and I like to measure the resistance, make sure there's no shorts from 5 volt to ground. That usually means that everything is where it should be, or at least it's not shorting. The voltage regulator chip, I notice as it cools down, the resistance starts to go up and up and up, so good to go. So, now that we've got a bunch of itty-bitty tiny boards done, now we can get to the programming part. So that's exciting. So, we've got our Arduino Uno over here as the ISP programmer. And we take our blank board, and we take our little pogo pins, and we go boop. You see we got the little green light over there. And now, over here, we got all this business. So this is just the thinger-dinger. So we hit C, and we hit Enter, and it verified the chip. So now we'll hit G to program, and Enter, checks the fuse, and boop. And now we've got yellow lights too. She's all programmed. Come on, you bastard. Yellow lights, yay. And we're done. On to the next one. So after the boards have successfully programmed, and I know I can continue, then we start working on the through-hole components. So this is stuff that you might be more familiar with. This is traditional old school. So we've got some Ethernet jacks on here, and some buttons, and some other stuff. So take your soldering iron and dip each pad and go to town. Oh, goodness. Doop, 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 doop. So after that, we got to assemble the screens. This is something I would preferably like to cut down because this is a little time consuming. Having to assemble the screens and solder all the pins and then clip them off. Because especially when I'm trying to assemble them, the more things you have to do, the more time it takes. That exponentially increases the amount of production time it takes. It doesn't look bad when you're doing one, but when you're trying to make 50 of them, it adds up. So stuff like this I try to avoid at all costs. That's why I'm moving over to SMD components, because assembly time goes down. And I can get them built by someone else, so that works out too. So then you get your little clipper boys and pop all these wonderful little pins off, because otherwise they'd short against the board. So after that, the screen is held onto the main board with a couple little headers. And then we get a few other little extra stragglers, like an LED indicator and a light sensor for bonus features. So this part is always kind of annoying, trying to make sure they're at the right height and they're aligned and all that, but just solder them all down, take another peek, make sure it's sitting where it should, reposition them, and then solder them all. I'd like to find an SMD solution to this, but it's hard to make them peek through the front as well. But there you go, that's what it looks like when it's all done. So now the final part, actually putting it into the case. So here we have some plastic. I forget exactly what kind it is. Traditionally, this is used for like windows and stuff like that, as like a glass alternative. It's tinted, but it's I think it's like a polycarbonate or something. I forget, but it's really nice as like a smoked out bezel. Because with LEDs, they're hard to read. Like they don't have really good contrast. So this helps the rest of the screen be dark. So that way the LEDs shine through and they're a lot more readable. Especially in like bright sunlight. This makes a huge difference. So we put a little cover on there just to protect it on shipping. We can pull the back off, make sure there's no fingerprints. And then we wiggle it in. So this is where good case design comes into play. I always try to do snap fit whenever possible, no screws or anything like that. So the tolerances on this are a little tight, so I gotta push kind of hard, but you get the one side is snapping. Usually I go for the buttons first. So once that clicks in, then we can pop the other side in, and it usually just kind of clicks right in there. Do a poof, pop, and ta-da. All looks good. Put the door on, plug it in, make sure it works, but there you go. That is how we built ourselves a nice little prototype. 3D printed and hand assembled. Look at that. Made in US of A. And then when it's all done, you get something a little bit like this. Yeah, sorry for the flicker, that's how it picks the screen up, but there you go. So now we got ourselves a little fan controller. We can turn the fans on. And the little light glows too. So I've been working on these a lot, getting all kinds of different settings and things. So I'll probably show off a proper demo of this at one point. But yeah. That's how the Trinity V1 prototypes were assembled. Get a little insight into all the tech aspects of things that I do, not just Jeeps. Nerd.